abroad. So we'll contribute him and give him to be the first, as he was brave enough. 2 foreigners canceled for this panel, but we have better speakers and braver Israelis, the pioneers of the solar energy business in Israel. Actually, we have an excellent panel here. You will see them all after they will speak. You will see them all here. I think there are those who know the Israeli solar business that started about, I think, 30 or 35 years ago. There are maybe 8 or 10 people that actually did or make it happen. All the good reputation that Israel has in the world was having. Now it's a little bit lower, but we have Professor David Feynman. I will make the introduction short because we started 15 minutes later. So we know Professor Feynman. You will hear about him more tonight when he's very humble, so I will not talk too much about him. But he's from Sde Boker. He's really a pioneer. Came to Israel, loves the country, and so enthusiastic that many of the young people can learn from him. Last night I saw him. I said, he's for me like entrepreneur. And this is really how I look at him. We have here 2 of the people that actually keep the solar energy business in Israel going and going. Avi Brenmiller, that everyone knows, he will always remain the CEO of Solel, not Siemens, Solel. This is the reputation. And Avi Brenmiller and Eli Mandelberg were a couple for many, many years that were, I admired them in such difficult situation, with almost no money, with an investor from Belgium that was not too large, I will say, with money. And they were traveling all around the world, not giving up. And you saw how much money Siemens paid for Solel. And it's mainly because of those 2 people. And this is a good chance for me to thank those 2 people that kept the solar business in Israel, because without Solel, I'm not saying that other companies are not good, but BrightSource was founded much, much later, also with people from Luz, but much, much later. And Solel was here all the time. Actually, I'm making a little bit of filibuster. By the way, Andreas Gast is here already. Oh, here you are. You are the first. Did you give I'm making filibuster now until you are coming. So you gave your lecture. Okay, so give me only, okay, until you give the lecture and you will start. So, as I've said, they were here all the way and actually enabled the Israeli government with the Shalim tender, but hopefully we'll see at least one station in a few years. And we have here a person that is a friend, but I really admire him, Pinchas Doron, who maybe part of you don't know of the name Aora or Edig, but for many, many years, he, on his own shoulder, kept this company with people that believed in the solar business, but did not believe in paying money, I think, I understand them because they were making money from other things and have vision, but maybe not long enough, but he did not give up. And he brought Edig or Aura to what it is now. Actually, it's the only, beside TRAF, the only CSP, solar thermal, concentrated solar thermal company that is producing electricity. The only one. With Israeli technologies that started at Weizmann Institute, started with the help of the Ministry of Energy. I'm saying it because I'm also an advisor to the ministry, so not everyone, you are ready. So if you are ready, 5 minutes, you need, it's not working. Okay. Maybe Professor Feynman would like to start or not? Because he has problem with because I think most of the audience are here now, and only say how I admire Pinchas Doron. I will say another word at the end. It's not only because I'm his friend. Professor Feynman. I have learned a lot from Professor Feynman. I will not talk much. I will let you start right away. The organizer, because of the light, I cannot see. Can you put Professor Feynman's lecture? Oh, here it is. Please. You have it. No, you don't see it here. You see it on the, but you see it here. I assume you can control here. Yes, you can control here. Okay, we start right away. You have up to 12 minutes. And after that, we have two minutes for Q&A. Thank you very much, Professor Feynman.
Thank you, Amnon, for your very kind but highly exaggerated words. I'm going to talk about PV, but I want you to understand that I love CSP just as dearly. It just so happens I didn't want to confuse matters as I only have 10 minutes. So I'm concerned with going from megawatts, which people are putting in at the moment, to gigawatts. And let me show you why. Okay, I'm going to try and answer the questions that Amnon circulated. So first of all, question number one that he sent us was, is there justification for electric solar PV system without significant storage? Now, we've published detailed calculations. My former brilliant PhD student, A.A. Solomon, on hourly output of the Israel Electric Corporation, and we found that approximately 20% of the country's annual needs could be provided by PV without storage. Two conditions. Sufficiently large PV system would need to be built that you would actually have to waste 5%, but no more than 5% of the annual electricity generated by the PV system. And it would be necessary for the Israel Electric Corporation to operate their grid at a technicality called flexibility value of 0.8 rather than 0.65. Let me just say quickly what flexibility is to those of you who may not know. It's a measure of the ability of the electricity grid to adjust very rapidly to changes in demand. And we analyzed the data very carefully, and we found that the Israel Electric grid is capable of operating at a flexibility of 0.8, which is good. 1 is the maximum possible. But for economic reasons, they operated it at 0.65. So if they really needed to put in as much solar as possible, they would need to change the operating strategy and operate it at 0.8, but it could be done with the present fleet of plants. So the answer to that question is assuredly yes. 20% of Israel's electricity could be provided by PV, and that means something between 6 and 7 gigawatts. Okay, here are the last 20 years of Israel's electricity generation as published by the BP Statistical Review of 2012. The last complete year that they have, of course, is 2011. The red line is the straight line is what will probably happen, and that means that by 2020, we'll be up close to 80 oh dear, transferring from Macintosh to PC, I see we've lost the scale. The vertical scale is terawatt hours or billions of kilowatt hours. Kilowatt hours is, of course, what we pay for our electricity bills. So this is billions of kilowatt hours. And by 2020, we'll probably be up at 80, but a slightly better fit to the data is a quadratic fit, which looks as if things may be leveling off a little bit, in which case, instead of rising at the steep rate of nearly 2 terawatt hours per year, then the slope at 2011 was only 1.24. So we can say that somewhere between 1.24 and 1.92 terawatt hours of additional generating capacity will have to be added each year, or very likely have to be added. And if we translate that into PV, we're talking of 730 megawatts to 1.1 megawatts peak every year. So this is why we need to be putting in gigawatts rather than megawatts. Because if we're putting in megawatts, we're really not doing very much. And if we want to do something significant, it needs to be gigawatts. Okay, so imagine a 1 gigawatt PV plant. I want to talk about 1 gigawatt. Where would we put it? Well, there are 40 Negev settlements, kibbutzim, actually 40 kibbutzim, I think. So if we were to put 25 megawatts on each one, there you have your 1 gigawatt. And as you all know, we already have one kibbutz here that has something like 12 megawatts, so it means simply doubling that. And on our tour this morning, Noam announced very proudly and fantastically that all of the kibbutzim in Hevel Eilot are going to have PV systems. So it's good, it's the direction, but please, Noam, a gigawatt altogether, and like it to be done all in 1 year. After all, a 25 megawatt PV plant these days is a very small plant. They go up very quickly. How much would something like that cost? Well, something like $2 billion US. And the question, of course, is, well, where do you get $2 billion US? A bank will give me a loan for a few tens of thousands of dollars for my PV system on the roof, which incidentally I don't have, because they know that if I default, they'll take my house. But they won't give me a loan for $2 billion because there's nothing they could take as in lien of that. So it's very difficult to get this kind of funding. But what we could do, what the government could do, is ask the public for a loan of 3.3 US cents for every kilowatt hour that they used in 2011. So if you use 10,000 kilowatt hours, you would loan the government $330. And you would get it back in 6 years with interest. How much interest? Well, let the Treasury decide. But the idea is a comfortable loan that you get back in a reasonable period of time with interest. So that's how you build, how you fund a 1 gigawatt plant and where you put it. Now, big question is such technology feasible? Well, ladies and gentlemen of the jury, last July I had the privilege of standing in the Gobi Desert at a place called Danhuang, and there before me was a 1 gigawatt PV plant. So big that actually I couldn't photograph all of it. It had the wrong kind of lens, so there's a little bit of it. So yes, the technology is feasible, and that's just the first of 7 gigawatts they're planning to put in just at that one lot in the next 5 years. So what would be the advantages to Israel of a 1 gigawatt PV plant? First of all, it's about as big a plant as you would ever want to build in Israel in 1 year, and it would give the Israel Electric Corporation a valuable experience, hands-on operating experience, how to manage that kind of input without storage. It would mean changing their operating strategy, that is, going from flexibility 0.65 towards 0.8. So it would be a very important laboratory for the Israel Electric Corporation. Secondly, it would be very important public education, just showing the public that PV is really not as bad, or solar is not as bad as one might imagine. I was invited to give a talk at a kibbutz recently that woke up one day in horror at the thought that they're going to have in their beautiful desert place mirrors as far as the eye could see. And they asked me, well, would you live in a place like that, and with all mirrors around? So I said, well, I've lived in a desert just like yours, just 20 kilometers away for the last nearly 40 years, and I've been dreaming of having mirrors like you're going to be given all my life. So yes, it's really quite beautiful, but let's not talk about aesthetics. So the public would get some idea of what PV looks like, and PV is, of course, one important aspect of solar. Secondly, it's very much in line with local business interests. Importers who are dreaming about a few megawatts can start dreaming about hundreds of megawatts. There's enough business for everybody. It's the first step towards a truly green future, because a 1 gigawatt plant would provide 3% of Israel's present electricity needs. Somebody asked, how should we provide 10%? Well, 3 of these plants, because my idea is build one first to learn as much as you can from it. And from time to time, if everybody likes it, build another one. So once you've built 3 of them, you're at 10%, and you can go as far as 6 or 7 before you need to start worrying about storage. And hopefully by then, all kinds of startups who are working on storage will have come to fruition. Of course, once you have truly big conventional PV plants underway, this will perhaps remove the fear that many decision makers in this country have of trying new local startup products, concentrator photovoltaics, small CSP plants, larger CSP plants. So look for those too. And also, if Israel can build 1 gigawatt plant every so often, everybody else could do it. So it would be useful to take the lead for something. Well, of course, the Chinese have already taken the lead, but in the Western world at least. So China, a very important part of the story, is their economic justification for CPV, concentrator photovoltaics. Because up until now I've talked about ordinary photovoltaics. Concentrator photovoltaics, of course, means that you use a very small amount of photovoltaic material and you capture the light on a very large area of mirrors or plastic lenses, both of which are lower cost. Now, China has a rising electricity requirement, which is quadratic. There's no way of getting away from that. And for them to do that with PV only, they'd need to put in nearly 300 gigawatts peak of PV panels every year. Now, they are doing fantastic things with PV panels, but this is really too much. In fact, their annual production has reached 20 gigawatts. They're actually manufacturing 20 gigawatts of PV panels per year, which is 15 times too small. So what could they do? Take 15% of their present regular PV factories and convert them into CPV fabs for cells that will operate at 1,000 suns. So this way, they have their 300 gigawatts per year, and these are the plans that they have. I won't read the numbers for you. Plans to put in gigawatts, wonderful, very impressive, but not large enough. They need to be putting in 300 gigawatts per year. They could do it. They have the necessary technology, and they have the wherewithal to do it. They have the internal need to do it because the climate is choking them to death with all of the coal-burning power plants. During 2011, 1.2 gigawatts of new coal plants went online every week. So what effect would that have on module prices? Well, if China decides to go PV in a big way, it might cause the world's supply of modules to dry up for a while. But then on the other hand, if they go to CPV, then that could release some, so they could recycle the simple PV modules to the rest of the world. So China holds all the keys. Finally, how is your company technology dealing with the price reduction of solar PV panels? Well, I don't have a company, but what is clear is that the drastic reduction in PV panel prices around the world has caused a major psychological problem in the investment world. Investors simply regard the word solar as a dirty word, and until this settles down, basically all solar and wind companies who don't have an alternative source of income going to be in very serious trouble and may not survive. Are we doing anything in storage? Yes, we're working on vanadium redox flow batteries, but probably I don't have time to talk about it. So, why bother? Very important. Why bother to work on storage? Because our detailed calculations showed that if you're prepared to dump 5% of your PV energy and you operate the Israeli grid at 0.8%, then Israel could produce 90% of its future electricity from PV, and the remaining 10% from fast-reacting gas turbines. What are the numbers that involved? Well, if I simply take the year 2006, for which we did the first set of calculations, in 2006, the Israel Electric Corporation had a fleet of altogether 10 gigawatts. Had they instead had 24 gigawatts peak of PV, 95 gigawatt hours of storage, and just 5 gigawatts of gas turbines, they would have been able to survive the worst week of the year, which is shown here, just without any brownouts. So the amount of gas backup would actually have been smaller than the total fossil fleets that they had that year. So, thank you.
Thank you. We have time for 2 smart questions. I cannot see with the light. Any question? Okay, one from this side, one from here.
Hi, Ray Wills. Just a comment.
Name, please. Your name.
My name is Ray Wills. Just a comment that you're better off with solar, in my view, competing with the retail price by having solar on domestic roofs than you are with large-scale solar in the desert. The reason for that is because with distributed generation, Australia has got 2 gigawatts of solar installed. It's all on rooftops.
Well, all right, you made a comment, and since I don't want to turn this into an argument, let me say that it's slightly more complicated than, I'm quite sure that part of what you say is correct.
Let's keep the comments to the end of the presentations. Hopefully we'll have time. A question, a short question from this side. Yes, here at the end.
Hi, Professor Feynman. Thank you for your words. Is photovoltaic, simple photovoltaic, the right direction for Israel to go, or should we be focusing on other technologies like CPV or CSP? Which is the best technical and economic way to approach what technology we should choose as our nation?
There are a number of approaches. I took as my starting point, we need to do something urgently. And when you want to do something urgently, you want to take what is off the shelf, what's available in large quantities. And there are basically 2 technologies which are available in large quantities. One of them is PV, and the other is wind. I've done the calculations for wind. It makes tremendous sense for Northern Europe, makes no sense for Israel. But I don't want to start a big fight, so I won't say why.
Okay, thank you, Professor Feynman. I will only the question was not towards me, but I will say that I think we should do PV and CSP, and we can make it now with people that are sitting here. It's only a matter of a decision by the government. No regulators, no tariffs, but to decide we need X megawatts in Israel, in PV and CSP. There are here companies that they can do it. We'll hear about it. We heard from Professor Feynman. We'll hear later in the 3 sessions about CSP. Now we have the brave guest from Germany that came here. It's not the first time that Andreas Gast is here. Sometimes in Israel, when you say inverters, People say SMA. Also, there are at least 2 famous companies here in Israel, but there are, I don't know if you are selling more, it's not important, but you have a good reputation here. Not so cheap, expensive, but good reputation. So now he will talk not about the inverters directly. It's a very interesting, I've not seen it, by the way, unfortunately, but the title is interesting, about utility scale PV in desert area, like we are here. Please.
Yeah. Good evening, ladies and gentlemen. My name is Andreas Gast, and
sorry. Try Axel, because here there is
okay, everything's fine.
sorry.
Good. Yeah. Hello. Good evening, ladies and gentlemen. My name is Andreas Gast, and at SMA, I take care for our customers and projects in Israel. Regarding this panel, I would like to make a presentation about utility-grade PV applications in extreme environments. And here I would like to focus on the example of desert conditions, because by making large-scale PV installations and PV installations in general, Israel is mainly, in Israel we mainly find desert conditions with high temperatures and also a lot of dust and sand in the air. So at first I would like to say only some words about our company SMA. After this, some news for Israel. So what are the latest developments from the side of SMA? And finally, I would present the technology for desert and extreme conditions. Yeah, SMA, our company, is 30 years old, and we made a turnover of 1.7 billion euro last year. We have round about 30% of the world market share, and we are represented in 21 countries. We are making all kinds of inverters for PV applications, on-grid, off-grid, backup, hybrid. Hybrid would mean, for example, photovoltaic diesel systems. And we do it for all sizes, starting with 2 kilowatt till there is no limit. So the biggest one at the moment realized with SMA inverters, the biggest site has a size of 500 megawatt in the United States. We have a production capacity of round about 10 gigawatt, 11 gigawatt per year. Last year we produced round about 8 gigawatt. The latest development is that we have opened service and sales subsidiaries in Chile, South Africa and Malaysia. And also in Israel, we will open in the next year a service hub to serve the demand for central inverters, because here a special know-how from SMA is requested. Yeah, regarding, I already said, we will open a service hub in Israel for central inverters. The first 3 projects will be realized in the first quarter of 2013 with a volume of 18 megawatt. And additional, we have a sales pipeline of additional 80 megawatt in Israel for central inverters. At the moment, SMA is the market leader in Israel for inverters. We have roundabout an installed capacity of 200 megawatt in Israel of photovoltaic inverters. Yeah, our service is modular, often required by the banks. So if it's maintenance, spare part guarantee, diagnostics and repair, or inverter availability, everything can be offered. Locally in Israel, 100%. And also something new is that starting from now, also transformers, compact stations can be offered. And the special point is that these transformers are working up to 50-degree ambient temperature, which is requested in the market and not fulfilled by all transformer companies. Yeah, what kind of system technology is needed for desert and extreme conditions? This is the question, and this is a very important question. If you see the experience of SMA on this map, you can see the blue lands. These are countries where We already have experience with large-scale PV projects bigger than 5 megawatt. The red countries, these are countries where we have experience with grid-connected PV systems with string inverters. So in the Sunbed region, so we call the region, we have a wide experience since many, many years, and all this information flew in the news developments of our products for these regions. This means especially desert conditions and tropical conditions, and this will be the most important market in the next years because here we have the biggest energy yield you can achieve. Here's some examples. The top one, this is in Abu Dhabi in the Emirates, where we reach temperatures up to 50 degrees and sometimes even above. It's in Masdar City. Another one, for example, you will find on the Cape Verde Islands on the west end of Africa. Also very harsh conditions, especially concerning aggressive environment because of the salty air. These are islands. Or in the Caribbean, in Martinique. Here, for example, we have a plant with 1 megawatt realized for a customer with central inverters where we find very harsh conditions regarding the tropics. And also you find installations in the mountains, higher than 2,000 meters, or in the next year also in the Atacama Desert in Chile, above 3,000 meters. Also very special requirements for the products, especially the inverter, with a lot of electronic, and you can say the heart and the head of a sort of photovoltaic system, which has to work for 20 years. Here's some examples. Other examples, I don't want to go in detail. Perhaps one, this is in Arizona. This is Agua Caliente, which is now realized with 250 megawatts. But you see, if it's in Arizona, Nevada, in the United States, in India, Thailand, everywhere already large-scale projects had been realized. What we have done is we have developed an inverter which is able to work from minus 40 degree to plus 50 degree ambient temperature. And here we use climate chambers who work from minus 40 to plus 90 degree to simulate the lifetime of an inverter in a development process and testing process of around about 3 to 6 months. During this time, we make endurance tests up to 1,000 hours with the inverter, changing the climate and temperature in very short periods. Additionally, we made laboratory tests for sand and dust, seismic qualification tests, and electromagnetation tests, which are required by many governments or even investors in the tenders. And when we're coming to the point now, here you can see 2 load profiles. One is in Munich, the other one in Israel. In Munich, in Germany, we have, even in the summer, maximum temperatures of 25, 30, sometimes 35 degrees. This would mean the inverter is working most of the year only at 40 to 50% of his capacity. You can compare it to a car which drives on a highway only with 80 kilometers per hour. If you put an inverter into Israel, into the desert, for example, north of Eilat, Idan, or in the region of Beersheba, this inverter will work most time of the year nearly at its full capacity, means between 80 to 100% of his capacity. And this you can compare to a car which is driving the whole lifetime with a full speed on the highway. And this means this car needs to be prepared and developed for these conditions. If you compare now the special specifications of the product, you can see the blue line, and the blue line shows the temperature curve in regard to the power output of an SMA inverter. And this means that he's bringing 100% output up to 25 degree ambient temperature, and then he's going slightly into the derating up to 50 degree ambient temperature, where he brings 100% output. Many competitor products also go up to 50 degree, but also already start the derating at 35 degree or stop at 40 degree ambient temperature. This is because investors, EPC and project developers have to take a special regard by choosing the inverter and especially looking regarding the output under hot and climate conditions. The result you can see here. On the top you see a graphic where every blue point stands for 1 production hour during a year. With an inverter from SMA developed for desert conditions, you cover all production hours of the year. By making a mistake, choosing a wrong inverter, you can lose between 10 and 20% of the energy yield of the PV plant. So it, for example, you say, okay, we put the inverter into a cabinet, and when we make an then we make an air condition. Yes, this is possible, but you lose additional energy by cooling the system. So this is something very dangerous for the investor and the project developer to lose a lot of money. So the product we developed for this market, for desert conditions especially, is called Sunny Central CP. He's working from 500 kilowatt to 1.8 megawatt. And to make a resume for you, SMA is a company with the strongest global presence and a first mover strategy. For example, here in Israel, we are now since 2006, 2007. We have worldwide installed more than 6 gigawatt of central inverters, means large-scale PV plants. In total, these are now with the string inverters nearly 30 gigawatt. These are, for the central inverters, more than 800 large-scale projects in 30 countries, only in 2010. And SMA is regarded worldwide as a highly bankable and solid company. Yeah, thank you very much for your attention. If you have any questions, please feel free to ask.
Okay, thank you, brave Andreas. 3 questions, but short. Please, questions, not comments. Yes. No questions. 4 questions. No one. You can ask in German if you want. No question. Maybe ask if it is the right time to buy SMA stock. You know, you are on the market, yes? I think so. I think it's low enough now. It's an advice, I don't know. Ask something. Oh, we have one. Please. Please, we want to hear your name.
I'm curious about what you are doing by the way of innovative inverters that are trying to enhance renewable integration.
Can you use the microphone, please? Yeah.
Is that better? There we go. Arthur Halbenstock, thank you very much for your presentation. I'm curious about what innovations SMA is undertaking to increase renewable integration through inverter technology.
So the innovations you see at SMA in the coming years are specially made for the markets where net metering is becoming very interesting. So we are developing products and solutions for the energy management of houses, industrial companies. This means, for example, in the next year we will see a 5 kilowatt inverter including a lithium-ion battery to increase the self-consumption of houses, or for example a product which is called Sunny Home Manager to increase the self-consumption of houses. This is in the field of the residential market. In the PPS market, so we call it utility market, here energy management for the utilities will become very important and is already important. In Germany, and this is a presentation of mine tomorrow, already the management by PV by the utility is requested. So active, reactive power, voltage and frequency control have to be managed by the utility and the PV field owner.
Okay, it was a good question, a good answer, so we'll stop here. Thank you, Andreas, thank you very much. At the end, you will come back to the panel, so we'll be able to answer more questions. Now we go to the CSP, and I am honored to invite Avi Brennmiller to give his speech, because Avi would like to tell us, you know, he could stop working now after he has achieved what he achieved, but he's continuing all the time. He's a workaholic. And he has a big view what could be done in Israel. And if there are anyone here from the government, please take notes and send it to the ministry committee on Sunday that will not destroy the CSP for Israel, because there is a huge decision, as all of you know, on Sunday. So please listen to Avi, send to all the ministers what he says. Avi.
Thank you. Thank you. So, today I'm consulting. Tomorrow I'm acting again in the market. Now, having this consultancy head, I started to think, what do we need here in Israel? Just Israel is the name of a country. It is true for many other countries in the Sunbelt. So I'll speak in English, but my presentation is in Hebrew, so everybody can get it. So what do we need? What are working assumptions when we are going to plan the future energy market in Israel? First, we need to supply electricity. Let's not forget about it. There is a growing demand. We saw some graphs, all of them, 5% per year. So somebody should really deliver this growth. Secondly, we need stability and reliability. Hey, we need the power when the sun is there, when the wind is there, but also when the sun and the wind are not there. And there is a price we have to pay to back up the time that those two renewable resources are not there. And there is a cost. What else do we need? We need target prices, constant prices, like many presenters here said today. And we need and we want to keep them stable for many years. If somebody is building a production facility, he's having his business model planning on energy prices, and then he's doubling or tripling his energy prices like we had in the last couple of years. We see what kind of crisis can happen. So we need those prices to stay for a long period. Yes, also we need those prices to be economic prices. We don't want to pay any extras. And if we pay extras for subsidies, then what is the solution? The solution, in my eyes, is hybrid power plants, which use both resources that we have right now in Israel. It's the natural gas and the sun. And those power plants will give us all or most of the points I had on the first slide. We also need distributed generation, but I would like to keep this generation as close as possible to the customer. Meaning, for example, one example could be others, that PV panels should stay on the roof and the power that they are producing, or the energy they are producing, should be consumed at the place of consumption. Don't think it makes a lot of sense to put those panels on the roofs and then send it to the grid and somebody will take care about this. It costs money to take care about it. I mean, even what you mentioned, Professor Feynman, just let's move the flexibility from 65 for pulse 085. It means money. It means a lot of power stations are out there idle when the sun is shining and coming to work when the sun is not shining. So maybe PV is a good number when you sell the PV, but the consumer will also pay for those idle power stations standing by to back up the PV panels. Why hybridizing? We put the power plant in place and then we have just dual fuels operating this plant. So we save infrastructure. The grid is one grid coming to the same plant. This plant with a nameplate capacity, 100, 200 megawatts, will always deliver 100, 200 megawatts. You can count on it, so grid efficiency is also increased. You double, when you put those hybrid power plants, you double the hours of operation of the power block, the power station. I mean, basically we need the power 16 hours a day, like from 7 o'clock in the morning until 11 o'clock at night. You know that this daily number of usage in Israel, for example, is 2.5 times than what we consume at night. So the most of the power is consumed during the day. So if we have 8 solar hours and we then operate another 8 hours with natural gas, then it makes sense we use 16 hours of consumption of the same power block. We also get some savings in emissions. We have some hedging. If something happens again, like we had with the Egyptian natural gas, the solar is hedging the cost of alternative fuels. So at the end of the day, if our hybrid plan is 50-50, we are hedging 50% of the rising cost of fuels, hoping it will not happen, but you know what? It might happen again. We consume less lands, we generate growth, green growth engines, and we add thousands of jobs in the country which is using this energy. It doesn't have to be Israel, it could be any other country who is deciding to implement this type of technology. We can use the analogy, you know, it's like the hybrid cars. You don't move from 100 years of fossil-operated cars to totally different technology because it's not reliable and the people are not accepting something which is not reliable. So the car companies, and I justify this decision, I mean, chose to go with the hybrid cars, and when the battery technology will improve and other technologies will come, eventually they will increase the electrical part and reduce the fossil part. The same logic works here. This is basically the operation philosophy of such a plant. You combine the natural gas with the solar at sunrise, and then during the day, you work solar only, and you even store some of the energy. A couple of words about storage. It's very complex in my eyes to store the electrical energy, and it's always 10 years away from us, and I guess it will always stay, or at least the next 10 years from us. It's too expensive and too complicated, but it's relatively easy to store in CSP because all we have to store is the heat. Half of the plant, of the 2.5 gigawatt plants in Spain today, are CSP plant with 8 to 12 hours storage. And so are similar plants which are being built, 50% of them in the US are with storage. So all we have to do is to reduce the cost of the storage, and this could be done through R&D. And there are a lot of suggestions, a lot of people working, but basically the basics are it's cheaper and easier to store heat and to store electricity. And then during the evening, you discharge the storage, and if you need more power during the night, or it's midwinter night and you need a lot of power, you operate it with natural gas. So the advantages is we are burning the natural gas at high efficiency, 52 to 58%, while if you could compare it to photovoltaics with a backup of a gas turbine, then you have 40% efficiency. We have smooth transitions. If a cloud is coming in, and it comes in with seconds. And you know, if you have 2 or 3 giga, 10 or 15% of your output in PV, you can't cover it out in few seconds, and it's on and off. Those clouds are coming on and off, and those guys who operated those power plants, solar plants, you know what I'm talking. There is no grid in the world that can really compensate in seconds. So in solar thermal or in CSP, this transition is very smooth. And we consume, at the end of the day, according to my calculations, using today's numbers, we save about 30% of the land. So my conclusion is sun and natural gas, join them together, and at the end of the day, let's speak a little bit about numbers. If you do this with current technology, and you hybridize a plant which will work 50-50 with solar and natural gas, you can come today for a number of around 60 agorot, around 15 cents. Now, we should not allow to stay with those numbers. This is too expensive. So I think that the government should put some cap on bids that will go out, a few hundred megawatts a year, with reducing the price every year, 1.2 cents, eventually getting to the number in 5 years of 35 agorot. It should be local, it should have local content. We need an O&M contract from the companies who are delivering the technology. They cannot just install and run away. And it could be financed from pension funds, because those plants, for those who don't know, they will operate for the next 100 years and continue to generate revenues. Those plants in the Mojave Desert are working since the mid-80s. And typical plant there, which was designed for 30 megawatts, with some upgrades in technology, is producing today 40 megawatts after almost 30 years. Thank you very much.
Okay, thank you very much. At the end of the panel, we'll have a chance, Professor Feynman, if you would like to respond to Avi's remark about the idle utilities, you'll be able to do it at the end, or someone else. Now, if you have questions about the concept that you heard, about the hybrid concept, or any other question, this is a wise person with a lot of experience. Please, questions. No question at all? For example, should you ask what is the solar factor of the solution? I will ask. What is the solar factor? How much gas, how much solar?
Well, I mentioned it in my presentation, it's 50-50.
Is it enough, you think?
Well, if you need it to be 75 gas because you need the power at night, then it's 75-25. It's up to you, but when I'm saying the demand is basically 16 hours a day and we have, on the average, 8 solar hours, it means we have 8 hours with natural gas, so it's a 50-50 mix.
60 agorot, you need 50%.
50-50. This is the number, yes. One more comment maybe, what I'm doing. So the consulting today is consulting. By the year end, we will turn ourselves into granular energy, and we will try our best to come from 60 to 35 agoros and develop technologies that will do this reduction of cost. It's not simple. It's not today available, but it will be hopefully in the near future.
But you think governments will accept it, 50-50?
Why not? I mean, at the end of the day, they are paying certain price for natural gas and certain price for solar. Why not join them together? If the deal is right for them, why not?
Yes,
why the government?
Like solar enough, you know.
Well, we can get to 10% solar share by doing 10% solar only and 90% other fuel sources. But you can get the 10 or 20% by joining them together. So it's just the mindset. We changed our mindset, we get our 10 and maybe 20% solar. By combining them together, we save the same emissions, but we give cheaper power. At the end of the day, to me, the most important part is that from day one, the customer will not pay more. Because if there is some kind of a hidden subsidy there, at the end of the day, it will not happen. You see the fights that are going here. I started Ashelim projects in 2003, and it's still a dream even today. So we would like to make it happen. So if you can get your solar by joining technologies, fossil and renewable, why not do it if you get all the targets which I mentioned here?
Okay, thank you. Any question? Okay, please.
Yes.
What is the price of gas you're taking into account? The price of gas per unit, per MMBTU, in this calculation.
I'm thinking about $7 to $8 per million BTU.
Bless you.
Okay. Having 8 hours of solar and 8 hours of gas, why not having 8 hours of solar and 8 hours of stored heat?
Well, I mentioned, I fully agree with you that the best would be to get storage. Definitely so. But I don't see the storage today. and I would like to see solar today. So I mentioned that while people develop the storage and come to the right numbers, we use hybrid. As time goes by and people will develop the storage, well, we can come to 75% solar and 25% natural gas. I mean, I don't see a situation where we'll cover all the 8,700 numbers in a year only with storage. Probably it won't make economic sense even 10 years from now. So we develop the technology, the storage technology, it becomes cheaper, we move to more solar, of course. This is the real key, the storage. But it's not here today, and I would like to see something happening today, still in my time. Yes?
We leave it to the end. Okay,
Thank you.
Avi. Thank you. Actually, what Avi says is that tomorrow morning we can do it 50-50 and to have grid parity or fossil parity. 60 agorot is like we pay, almost like we pay today. In the future, we'll have storage, it will be higher. This is actually what you say. We can start tomorrow morning. Don't have to wait for further developments. Okay, we have now two companies that I have to say are my favorites, and I think both of them, I hope, and I assume so, will bring much proud to Israel in the near future. The first one is Heliofocus. Eli Mandelberg, please come to the stage. I mentioned you before, you together with Avi Brennmiller gave life to Solel. And Heliofocus, I'll say only two things about Heliofocus. First of all, there are two brains behind Heliofocus. There are very good people in Heliofocus. Part of them are here in the panel. One of them I did not see here is Professor Jacob Carney, who developed a receiver that was funded in the beginning by the Ministry of Energy as a research. He brought it to the company. Around this receiver, now there is a more developed concept. They developed an entire concept that Eli is the brain, I can say it, behind the entire concept, behind the technology, is a real asset for that company. And I'm happy that he can share with us only one niche of Heliofocus, which is the hybrid solution. Please, Eli.
Okay, I will start with a short review regarding hybridization. Try not to repeat what Avi have mentioned, and look at it with a little different concept, and then give some samples of what we are doing in Heliofocus concerning combining solar energy with fossil fuel source. החצים פה לא עובדים? העברת הסלייד? כן, אבל זה לא עובד. פה? החץ הזה? אוקיי. Good. Okay, just a little reminder, one of the issues that were mentioned before, the benefit, the overall benefit from renewable, overall benefit of CSP is mainly, except the fact how much it costs us, what is the cost of kilowatt hour, is the storage option and hybridization. A little bit review about the storage, just giving the even a little bit history about what happened in Israel regarding decision on hybridization. Why do we need storage? Why do we need renewable? Why do we need solar? The reason from the national level, except the cost effectiveness, of course, is the willingness to put new technology, establishing new energy, benefits at national level. And hybridization is a huge opportunity to widely apply CSP, supporting this concept. As was mentioned before by Professor Feynman, solar cannot solve all energy demand. If you look at, I would say, a concept of applying maximum solar on solar factor 1 regarding the demands of energy, 20 to 25% can be achieved if we apply solar-only power station. Now, if we look at this concept and agree that this is the amount of solar that the company, the national level of decision want to support, that we combine this amount of energy together with gas using hybrid system. This way, the overall cost of energy, of solar energy, would be much lower. And this is the reason, this is the main reason why should we go to hybridization. I want to comment something. At the time when we started to work with the government on setting up the overall cost for CSP technology, David Asus, if few people remember him, had a concept saying that he wants to put solar power stations that would be able to operate with no gas. The reason for that, there was no gas, and there was no oil. And at the time, Danny Sagi, Danny, are you there? Yeah. Made a wonderful work presenting him the numbers, showing them that hybridization option is much more cost effective. His decision at the time when it was decided was quite logic. Gas was not available. That nowadays, the picture is completely different, and there's no reason why the government shouldn't let solar energy be cheaper. Going hybrid means cheaper electricity cost. So the concept is very simple. I think that Avi gave a brief description of that. Whatever comes from fossil fuel should compete in the market. Solar energy should get the calculated benefit, not 1 cent more. This way, we would get to lower prices of electricity, lower than what we get from IEC today. If you people had the opportunity to see what researchers around the world thinks about it, either in the Sunshot program, which was done mainly by PV people, still, the bottom line is going hybrid. It's the most reasonable way to take part of the fossil fuel energy, integrated it together with solar, get lower prices, widen the market for solar, and having much more benefits at the national level. Usually, I'm asked, what do you mean hybrid? Hybrid, for me, it's a combination, and it doesn't matter how it is combined. Either parallel operation of solar with gas, or working during the sun only with the solar and then adding gas. At the end of it, what does matter is how efficient can we supply a hybrid system if we look at the ratio between solar to gas. Avi mentioned 50%, and people over here ask why not more. At the bottom line, it's economical decision, that's it. If we manage to do it, if we can compete, this is where we are tested. So, a little bit on HelioFocus, what we are doing. HelioFocus is working at high temperature, generating hot air, using this air to generate steam. The main product we are developing, actually, I don't like to call it hybrid because the solar part work separately, supplying energy, but we are using an existing power plant, which means the investment, the capex is already there, and we are just adding steam to the combined cycle or the coal power plant, where the main difference is when working in combined cycle, we actually produce more energy than the combined cycle would have delivered without the solar. And with coal power plant, we are just saving coal. So first question how come you are delivering steam instead of coal? The cost of coal in terms of competition between cost of solar to cost of coal, nobody would be able to do it. You know, in China, the equivalent cost of coal, it's about 0.5 per million BTU. Even in solar, you cannot reach this number. So the reason for that is the additional benefits. And a decision of the government to support such technology in order to reduce the amount of coal burn. As Professor Feynman mentioned, if you go to Inner Mongolia at the northeast side, there's some parts you never see the sun just because of the coal power plant. So what we are doing, we are adding steam, you can see in the picture, to an existing combined cycle. This is a demonstration of Ramat Chovav project, where the first stage of this program is installing an equivalent of something between 0.5 to 1 megawatt, adding steam to the combined cycle. Steam is delivered through the main line, meaning if the combined cycle is consuming steam at 540 degrees C and 80 bar, then this is what the combined cycle gets, utilizing the maximum efficiency of the combined cycle. In Ramat Chovav, it's a relatively old combined cycle, which means they have only 2 pressure level, but we can adjust it to whatever is demanded. In a more modern combined cycle, usually it's pre-pressure level, temperature much higher, and much higher pressures. But from the point of view of the solar system, it really doesn't matter. Of course, we get benefits from the higher efficiency, meaning more electricity per generated ton steam. This is a sample of a 3-level combined cycle where the solar is delivering steam in parallel to the steam delivered from the heat recovery system of the gas turbine. In hot summer, we are really adding additional electricity to what the combined cycle can supply due to the higher temperature and the reduction of the gas turbine performance. We have been talking about China. This is our project in China. If you look at time schedule, in less than 6 months, this is the system already erected with the foundation and everything. In less than 6 weeks. Things are going there very fast if you want to apply project. I heard that Yom Tov talked about it in his lecture. It's quite clear that applying project in China is much easier, and in a way, I think that we should learn from them. Thank you.
So accurate in time. So we have 3 challenging questions. No question, everything is understood. Would you invest in heliofocus? No, they don't need your money, but no question. Temperatures, everything. What is the future? Innovations, next steps. Okay, we'll leave it for they're so good, you don't have to ask questions. You were good. Thank you, Eli. We don't have much time. Pinchas Doron. Yes, you can give applause to Eli. Pinchas Doron is a friend, is an excellent engineer, started many years ago, but he was at the solar tower at Weizmann Institute, jumped, I don't know, 15 years ago to the cold water of the industry. When did you leave Weizmann Institute? 15, 16 years ago. Jumped to the cold water. Now he's leading, as I've said before, the so far only CSP company that actually is producing electricity from the sun with high temperatures. I appreciate you very much. I will not talk too much because he's my friend. Pinchas, please.
Okay, thank you. I guess you can see this. First of all, good evening. It's my luck to be the last speaker of the day, I believe, not just this session, so I'll try to be brief. Especially, sorry? Yeah, okay. And also my job has been made a lot easier because the excellent speakers before made the very good arguments in principle for this concept of hybridization. Let me just add a note, since we are here in an Israeli organized conference and looking for innovation and vision for the future. Go back almost 20 years ago to the first CSP conference that I went through, and then when people heard us Israelis speaking about hybrid, they got very nervous, very angry, very glassy-eyed, and thought of us as being those crazy people coming from the Middle Eastern desert. And now everybody's actually just arguing why the other ways are not really feasible. So that's one comment. Then it will be easy for me to add some comments about implementation of hybrid system for a solar thermal plant that operates at very high temperature, running a Brayton cycle, an air turbine. So you need to have the temperature, the thermal input at close to 1000 C, which, as Avi said before, is really way into the future as far as storage goes. And what you see already on this slide is our actual system, which you will see again later in Spain, where it's working with the sun. And you can see those clouds a little bit in the background, which you will also, I will demonstrate how hybrid can deal and can deal best with such situations. So one additional comment refers to the distributed generation as opposed to very large centralized plants. So in our case, we go to what some would consider very small, maybe some would consider too small. We think it is a very good solution because it can provide this power at community level. And there are other people striving to that as well. And going to a hybrid solution, which is in a solar thermal configuration, would allow you to provide a comprehensive energy solution, which would give electricity and heat, because you have exhaust heat, and you can do it scalable, and being hybrid, you can assure a solution. You don't just provide solar electricity, you provide a solution, a comprehensive solution. And when you consider the topic of this session of being for hybrid, and at least before people were talking about hybridization of solar with fuel, and immediately what comes to mind is fossil fuels, then why fossil necessarily? I mean, you use whatever you have that is economical and that is best suitable and that is desirable. And thereby you can also have the non-solar part also not as bad and dirty as using any fossil fuel. Because you could use biogas, you could use biodiesel, you could use whatever other people who are doing great job in producing renewable fuels are doing, and combine them with this system. And you can think about a lot of configurations where actually you would use some of the output of the hybrid plant to generate your own fuel. So you have a kind of what the people in the nuclear industry like to call a breeder reactor. You would have a breeder solar thermal hybrid system. So these are all opportunities that are offered by the hybrid system. And just to show you how this thing can really work, then this is the plant that you saw before, and we have one working in Almeria in Spain at the Plataforma Solar, which is, most of you know it probably, but it is a big technology demonstration center. And we have that system that is working right I mean, not right now, but because we just turned it off for the night. But you can see it on the Arava Road about 30 kilometers north of here, in Kibbutz Samar, just 10 kilometers before Yotvata. And these are an implementation that demonstrates clearly the advantages of being hybrid and the advantages of being distributed. This system that you see in Samar and the fence that you see around it, it's just to keep, basically to keep the kibbutz children from wandering in when you don't want them to. But it's within the community outer fence. So we can save on security, that's fine. But this demonstrates also that you can put it at the customer, and being hybrid would allow you to integrate with all other both products and needs of that community. And the way that we consider this hybridization is in a micro gas turbine or air turbine, where we maintain the fuel burning capability and add the solar part as a possibility. Both of them are a possibility. You use sun when you have it, you use fuel when you don't, whatever fuel, when you don't have the sun, and you can add fuel whenever you don't have enough sun, which is also a very important factor that hybridizations allow you, which is to maintain a constant and reliable level of power production, because you're not really dependent on how much the sun gives you at any given moment or second in time. And I spoke about the clouds coming in. I have a very small example, don't really consider it as totally representative, where it shows a time when the solar irradiation was not high and was highly changing. And you will see that the green line, which is actually the power output, is almost constant. The red line is the solar irradiation. The blue line is the fuel feed to the system, and you can see that you can manage the power output and adjust the fuel addition and take overcome all these huge variations in the solar input. And I would like to thank you, and I would welcome your questions.
Thank you, Pinchas. I need to correct something I said before, that it is the only CSP that is producing electricity. Of course, I meant the only one in Israel and the only one with very high temperatures. I did not know if you mentioned temperatures here. I did not hear. If you want to mention, but...
Yeah, well, I did mention temperature by way of saying that we're running a gas turbine which runs at a very high temperature. Well, I'm referring to close to 1,000 degrees C. And obviously, as I mentioned, thermal storage at 100 degrees C, well, we have to live and see it.
Okay, thank you. And of course, they can use biomass instead of fossil fuel, so I think it was mentioned. Any question? Question. Okay, here.
Is it open? Oh, hello. Michael Morris, Yagod Morris, an Associate Patent Attorneys. I wanted to ask you actually about your thank you slide. In the thank you slide, you show a theoretical field of lots of mirrors with various different solar towers. And actually, it made me wonder how big can the field be for one tower? Because there must be a limiting factor And I was wondering how many kilowatts can you get for each tower? And like you showed in your thank you slide, surely you're going to have to multiply the whole thing up every time you want to increase on that.
Well, our concept is being modular. Being modular meaning that, we have it. You will notice that basically the difference between those units in this rendering is color. And it actually originates from our architect who designed that beautiful flower. But the idea in being modular is that basically you can go down as the size of your base unit, and then you can go as big as the multiples of that base unit. In the present configuration that we're working in, our base unit is nominally 100 kilowatt electric, and achieving a higher capacity is done not by increasing the size of a single unit, but by putting more units all together. And we can discuss a little bit about the advantages that we consider in such a configuration. But
thank you.
We are continuing for more 5 minutes. I would like to ask all the presenters to come to the stage, also you, Pinchas, so we can continue with questions. And one question, please come here. One question that I have to each of them with a short answer. The title of this panel was Commercial and Future Technologies. So now, if everyone can predict what they think will be or should be in the near and the far future, especially what the development should be in technology, temperatures, gas turbine or air turbines. I hope you notice that Pinchas said air turbine, because they're not using any gas, they're using hot air, high temperature, which is very important. Okay, any question from the audience? No question? Okay, please.
Hello. And I will ask you about, we have seen some predictions about the price of photovoltaic modules. I want to know if you can give us some future about price of inverters. Of course, it's for Andreas.
Yeah, so if you see the price development in the last years, also the price of the inverters dropped down rapidly and strongly. And last year, our management board announced that in the next 5 years, also the prices of inverters will drop down by 50%. So we assume that in the Middle East region, other sunny countries, the price for a kilowatt hour to be produced can reach 6 to 7 euro cent per kilowatt hour in the next years. And the inverter is one part of this system bringing down the costs. This is what we are working on every day with our 700 engineers.
Okay, thank you. Another question? Yes, please.
Thank you for your very kind lectures and the presentation. I am coming from South Korea, representing the POSCO group, and I have office in Tel Aviv. I am one of the friends of Eli Mandelberg. I will see you after this session. So I'm going to comment 2 kinds of questions. I don't know if it should be a comment or questions, but first of all, here, you Israeli industry about this solar-related renewable energy. talking about the resources, the sunbeams, thermal arc resources. So all of you are talking about resources in Israel. But basically all these energy system, which is bought from foreign countries for Israeli industry, should combine many parts like SMA from Germany and any other BOP infrastructure from any other Asian countries. Also, you have to buy, if you are talking about PV or CPV, you have to buy all the infrastructure from foreign countries. So in this sense, this is not enough. I mean, talking about renewable energy industry in Israel, all the topics today is not enough at all. So if we are talking about, again, future renewable energy system, we have to consider the turbines, whatever it is, gas or steam, or you have to buy the turbines again from famous turbine
Do you
makers.
have a specific question, please?
So I'd like to comment.
Excuse me, one moment. Do you have a specific question?
Yes, I have.
We are here not for comments, for questions.
So my question is, do you, all of you, have any specific ideas how you develop using the whole this kind of utilities in Israel for achieving your goals you mentioned today? Especially for, I forgot his name, of the consulting company who presented the future concept, probably can answer about this my question.
Anyone would like to respond? You can take for.
For sure, during the presentation, we didn't relate to that, but for sure, in order to get into the real optimization point for operations such hybrid system, we should try to do it together with suppliers of power blocks or turbine system, which in Israel are not available. I think that most of the high concentration CSP companies are trying to hook up with such supplier in order to optimize the system. We cannot avoid it, especially if we want to get the price as low as possible. Optimization and integration is part of the deal and has to be done very wisely. And actually, in your question, there was the answer. We need to deal with it and we need to put effort into it.
Anyway, bless any cooperation, of course. We need it, actually. Anyone else? Yes, Professor Feynman. By the name, my name is Amnon Samid. I'm sorry I did not introduce myself. Professor Feynman.
We have a global problem, you and I. Something like 20 countries are generating at the present time 80% of the world's electricity. Israel is not one of them. We're generating about 1/3 of 1%. We have an energy problem in Israel, and it would be wise for us to develop the kind of technology that not only can solve our energy problem, but can be exported and help the rest of the world. So from this point of view, industry is a global industry, and the more generalized the solutions are that we find, the more suitable they'll be for your country, for our country. The details, of course, will vary according to the climate and according to the local economics, etc. But the basic building blocks, whether they will be 5 megawatt wind turbines or 100 megawatt CSP fields or 10 megawatt CSP fields or gigawatt size PV or gigawatt size CPV, these will be the basic building units. You wouldn't put a CPV plant in Northern Europe. You'd put it in the Gobi Desert, for example. And you wouldn't put wind plant, which requires thousands of square kilometers, in a very small island, which simply doesn't have the land available. But you might put them out at sea. So these kind of units are being developed in all countries of the world, or many countries of the world. Each country is developing naturally the kind of technology that will solve its own problem, but thinking in terms of global business. So your question is a good one, and I think that there is a positive answer that's going on, and Israel is a part of that answer.
Okay, thank you.
One more comment, please.
Oh, please, Avi.
Just to understand, we need to get, in my eyes, to 10 cents per kilowatt hour. I think 9, 10 cents per kilowatt hour. If you just have the basic calculation of today's cost, you'll never get to 10 cents without going out of the box or breaking the rules of the game. So first we need to find some good ideas. How do we come to those numbers? And then, of course, in order to implement, we must have the big players of the world, the big balance sheet companies that will help to really implement. But first, the first target is try how do you get there to those 10 cents per kilowatt hour, because if you don't get there, there is no future for this kind of technology. Because at the end of the day, as I said before, people are caring about the cost and they are not willing to pay a lot of extras.
Okay, thank you. Hope you are satisfied. Yes, please.
Hello, thank you very much for your presentations. My name is Sergio Finger. I work for Capital Nature. And during the presentations, I was wondering about, you said about clouding and interruption on solar. So I was wondering if there's any way of generating a buffer to cover these periods of clouding, or also extending this concept. Can you, at the time you generate surplus for the night periods that you won't be able to generate solar? And also, a second question, can you generate any kind of liquid using solar so you'll be able to transport it and also to use it during night? Thank you very much.
Okay, who would like to respond? Andreas first, then Pinchas.
At first, I want to say that from my perspective, I do not understand the discussion about there is coming something, how you call it, a cloud is coming and shadowing the panels or the solar. Because in Germany, for example, we have already installed 30 gigawatt of photovoltaic. And on sunny days, on a weekend, for example, during midday, 30% up to 40% of the complete electricity in Germany is generated.
So these are the two aspects of storage. I wanted to say one other thing, if I may. I unintentionally started a war between CSP and PV by the final comments that I made in my presentation. I want to make it clear, and I said to begin with that I personally love CSP, and I hope it has a great future. I think that CSP and PV, and put a few other things in there, CPV certainly, have a number of challenges that have to be overcome. But these challenges are all engineering challenges, and I'm confident that they will be overcome. So today, to say, well, you know, CSP has the advantage that it does so-and-so and PV doesn't, well, for every one of these, you can give an advantage that PV has that CPV doesn't, and this is a silly game to play because both technologies are too young. We're at the stage where we desperately need to be putting things in. I indicated that the scale that we should be working at is not the megawatt scale. We should be working at the gigawatt scale, and unfortunately, the only two technologies that have been developed, that have been demonstrated today at the gigawatt scale are PV and wind. Historically, CSP has proven to be the most reliable of the renewable technologies, in the sense that it's been around longest and it's still operating. And ultimately, reliability is the name of the game. Nobody cares about efficiency or anything like that. Ultimately, if the system works and it works and it works and it works. So this is what CSP has over everyone else. But in terms of what has been demonstrated to date at the gigawatt scale, unfortunately, CSP has only been demonstrated at the hundreds of megawatt scale. Similarly, CPV has only been demonstrated at barely at the 1 megawatt scale. But in China, there are PV plants and wind plants in excess of 1 gigawatt, that's 1,000 megawatts at one given place. And since it's been demonstrated, it's doable. And that's what I was discussing. I wasn't trying to imply that I think PV is superior to CSP. And one of the caveats I said was, once a government sets itself the tasks of implementing renewable energies on a large scale, obviously you start by building one plant with off-the-shelf technology, and if that off-the-shelf technology has to be imported, you import it. We buy refrigerators, we buy cars, we buy all kinds of things from abroad. But that doesn't mean we have to replicate it year after year after year. Once you start doing it, it would hopefully open the eyes of the government to the fact that we have a large number of very innovative companies here in Israel that are falling apart for lack of proper investment, because everybody is blindly thinking that PV panels are so cheap, they're the future. And they're the present and they're the past. If they're going to be the future, we're simply going to cover the world with silicon panels and using 1960s technology, and that's a shame.
Professor Feynman, 5 years from today, which technology will be, which family of technologies will be in the market?
I'm sorry, I'm not a
5 years from today.
I'm not a prophet.
No.
It will depend
That's what I'm asking you, because you are not a prophet.
It will depend purely upon the psychology of the investment market and the psychology of the investment market.
What is in your mind? What are you working on? What are you working on these days for the future?
In the long-term future, I see, but it's just a very narrow-minded. I think that in the long term, concentrator photovoltaics and electricity storage will be the answer for Israel. It won't be the answer for everyone.
But which technology? You think dish, you think trough, you think solar tower, you think 1,000 degrees, you think hybrid, you think... What do you think?
Well, of course hybrid, because part of the system will be gas turbines.
So you don't think that we'll have viable storage in 5 years from now?
What kind of storage? Electrical storage?
Whatever you think will be visible.
Hopefully, but I doubt in 5 years. One of the things we will have, if plans go according to announcements, we may have a situation where we have 2 million electric cars. And 2 million electric cars, each with a 50 kilowatt hour battery, is 100 gigawatt hours of storage, which just happens to be the amount of storage that we need in order to have a 90% solar, 10% gas system. But that's just a coincidence of numbers. I would hope that we would have a very serious part of solar thermal in the mix, it wouldn't all be concentrator photovoltaics, and I hope that there would be some, I won't say old-fashioned PV, but new generation PV on people's houses, perhaps in their windows, to do all kinds of things that a future smart grid, if I can use a buzzword which is very popular today, will allow. And not only that, I hope that a future will see Israel connected to our neighbors,
Palestinians. This is...
No.
We are technology panel here, okay.
It's all part of...
No, I agree, but we are concentrating on technology.
The price that we pay for electricity and the technology that we use is basically a political decision.
Yes, but we are talking here...
In any country.
I think most of us are from the technology side, not from the political side. So let's do what we can do. Okay. Maybe we'll start with Eli. What you see will be the future from technology point of view.
I'll try to summarize it in a few sentences. As Professor Feynman said, it's hard to be a prophet, but at the end of it, I assume that will be a mixture of technologies, because each technology have a certain advantage for a certain market, for a certain target. From a point of view of a CSP technology, I think that hybridization with CSP is a natural solution for the grid controller at the national level in terms of what is needed to invest in infrastructure for covering the demands of the country, the electricity requirement. Hybridization is needed to reduce the prices and to support a stable supply of electricity, where cost effectiveness is going to be the real judge which technology will be, I don't know, it shouldn't cover the whole market, but will have the most dominant market fraction.
Okay, thank you. Avi?
Not much to add. I believe that the technology which will reach to 10 cents per kilowatt hour and will be able to supply stable supply to the grid will be the winner. And I believe it will be a hybrid, including elements of thermal storage, not electricity storage. And whoever gets there will be the winner. We hear about smart grids. I don't know what smart grid means. I mean, if there's no power there, I'm not sure what smart grid will do. But I would like that each one who is supplying power, either it's a big power station or it'll be our rooftop to deliver power whenever it's needed. So eventually we will not need really very sophisticated grid to cover for all kinds of transients. So 10 cents power, it will mean higher temperatures, higher efficiencies, lower cost, a lot of industrialization, which is just starting in some of the technologies. This will all lead a lot of innovation. This will all lead to this 10 cents power. We don't know who the winner is, but the one who will be there at those numbers will be the winner.
Okay, thank you. Andreas, please make it short.
Yes.
Because we have very few audience here
I make
left.
it short. So I see three major trends for the photovoltaic and especially inverter technology in the future, let's say also in the near future. Point one is for the residential market. Here, the increase of auto consumption, net metering, and energy management in households will become more and more important. This will be in all markets where we have reached already the grid parity, like in Germany or Italy, and in all markets where grid parity will be reached. This is the case, for example, in Israel, but also in countries like Morocco, Ghana, South Africa. The second trend I see is the hybridization. So SMA developed a control unit to hybridize diesel generators with photovoltaic. This is already in use, and for example, last month a customer of SMA installed a 1 megawatt photovoltaic system combined with a 2 megawatt diesel generator for a mine in South Africa. And I think we will see in the next few years, 4 years, gigawatts of hybridized diesel generators in the world.
Okay, thank you.
And the last trend,
okay.
This is the utility market. This means big solar plants will be installed worldwide, delivering the cheapest kilowatt hour during peak time, daytime.
Okay, thank you. Pinchas, also please make it short.
I'll make it short. Well, one comment is that contrary to the way that Avi said, I much more agree with the way Eli said, there will be many winners because there are many applications and I don't think that there will be a single winner for all of them. One thing that I do need to mention, a lot of people here mentioned connection to the grid, gigawatt scale, and so on. There's a lot of people on this planet who don't have a grid at all. And they also will need a solution, and not in the very far future. And while making and building grids will be a solution in some places, in many of them it will not. So there's a lot of place in the future for distributed, localized solution to communities at the community level.
Thank you, Pinchas. Actually, I wanted to talk about it, but we don't have time. Pinchas Doron, Andreas Gast, Professor David Feynman, Avi Brenmiller, Eli Mandelberg, thank you very much. Thank all the audience that are here until 8 o'clock. And 10 after 8, now we have a gala evening, and enjoy it. Thank you very much. Thank you, everyone.